Hello, this is Dr. Ayanshola Ogundele, Astronautics for Exploit. In-Situ resource utilization, harnessing of space-based resources for deep space exploration. The focus points of my presentation are as follows: In-Situ resource utilization, In-Situ resource utilization proposed locations, and In-Situ resource utilization models and technology demonstrations. In-Situ resource utilization, the use of extracted and manufactured abundant natural raw materials and energy sources found in situ on the Moon, Mars, asteroids, and hosts of others is a necessity and cornerstone for the actualization of deep space exploration plans and key to the establishment of permanent human presence in space. The use of in-situ resource utilization developed materials will help to reduce the cost of transporting raw materials from the Earth to the Moon or Mars and time required for the transportation. The lunar bases will be useful for the resupply and refueling missions going to deep space. Several ideas of lunar bases have been proposed, and virtually all the proposals revolve around in-situ resource utilization idea and 3D technology. Presently, the cost of launching payloads to the Moon is very expensive, but being able to use lunar resources will help in reducing the cost. Some of the valuable and tangible resources found on the Moon, Mars, and asteroids are water, oxygen, volatile elements, regolith, and minerals such as iron, nickel, iridium, palladium, magnesium, rare earth elements, and atmospheric gases. Solar energy, radiation, ultra-high vacuum, and low gravity are also found in the vicinity of Earth, planetary bodies, and the vast space between them. The locations identified for the establishment of in-situ resource utilization are the Mars, Moon, Martian moons, Ceres, asteroids, moon, and planetary atmospheres. Research on the location of ISRU on Mars is focused primarily on providing rocket propellant for a return trip to Earth, either for a crewed or a sample return mission, or for use as fuel on Mars. Various in-situ resource utilization models and technology demonstrations have been put forward. The Mars Surveyor 2001 lander was intended to carry to Mars a test payload that will demonstrate manufacture of oxygen from the atmosphere of Mars. The Mars 2020 rover mission included a in-situ resource utilization technology demonstrator. The Lunar Resource Prospector rover was designed to scout for resources on the polar region of the Moon. In-situ resource utilization is the collection, processing, storing, and use of materials which are found or manufactured on other astronomical objects such as the Moon, Mars, and asteroids. In order to reduce cost and time, the use of materials found on the astronomical objects are being proposed instead of bringing materials from the Earth. This picture shows in-situ resource utilization concept for future mining of space resources and exploration of Mars, Moon, and beyond. Space resources, materials that can be found outside the planet Earth, have potential economic values. Near-Earth objects such as asteroids are perceived to be rich in carbon, metals, or silica. This picture shows ISRU system concept for autonomous robotic excavation and processing of Mars soil to extract water for use in exploration missions. Water, oxygen, volatile elements, regolith, metals and minerals such as iron, nickel, iridium, rare earth elements, non-metals, and atmospheric gases are valuable tangible resources. This picture shows ISRU system concept. Solar energy, radiation, ultra-high vacuum, low gravity are also found in the vicinity of Earth, planetary bodies, and the far space between them. This picture shows illustration of a moon base, which could be built using 3D printing and ISRU. Uses of space resources. The space resources could be used as raw materials, sources of energy, to support deep space exploration and human survival on the Moon, Mars, and beyond. Solar energy could be used to power spacecraft and locations in various orbits around the Earth. It could also be used by communication, weather, and global positioning satellites. This picture shows artist rendition of the International Moon Village. ISRU proposed locations. Some of the proposed locations for the establishment of in-situ resource utilization are Mars, Moon, Martian moons, Ceres, asteroids, and planetary atmospheres. This picture shows artist's concept of a lunar base. ISRU location on Mars. Research on the location of in-situ resource utilization on Mars is focused primarily on providing rocket propellant for a return trip to Earth, either for a crewed or a sample return mission or for use as fuel on Mars. Many of the proposed techniques utilize the well-characterized atmosphere of Mars as feedstock. This picture shows concept of lunar flashlight in a position over the south pole of the Moon. A proposal for ISRU is the use of a Sabatian reaction in order to produce methane on the Marian surface to be used as propellant. Oxygen is liberated from the water by electrolysis and hydrogen recycled back into the Sabatian reaction. In-situ production of oxygen, hydrogen, and carbon monoxide from the Martian hematite deposits has also been proposed. This picture shows artist's concept of NASA's Mars 2020 rover exploring Mars. SpaceX is developing advanced technology for a Mars propellant plant. Rather than transporting hydrogen from Earth to use in making the methane and oxygen, SpaceX intends to mine the requisite water from subsurface water ice, produce and then store the post-Sabatian reactants, and then use it as propellant for return flights of the Starship. This picture shows illustration of a proposed industrial base for mining water and producing propellant at a lunar pole. Extraction of carbon dioxide and production of oxygen on Mars. Research findings show that the resources required to make plastics exist on Mars. Many of the complex reactions can be completed using the gases harvested from the Martian atmosphere. It has been suggested that buildings on Mars could be made from basalt as it has good insulating properties. This picture shows depiction of NASA's plans to grow food on Mars. ISRU location of the Moon. The Moon possesses abundant raw materials that are potentially relevant to a hierarchy of future applications, beginning with the use of lunar materials to facilitate human activities on the Moon and use of lunar resources for industrial capability within the Earth-Moon system. Natural resources found on the Moon include solar power, oxygen, water, hydrogen, and metals. This picture shows artist rendering of an efficient lunar mining facility. The lunar island material anorthite can be used as aluminum ore. More natural resources mining proposals have been also put forward. This picture shows artist's conception of a lunar base. ISRU location on Martian moons, Ceres, and asteroids. In-situ resource utilization has also been proposed to be located on Phobos and Deimos. These moons are in reasonably high orbits above Mars, have very low escape velocities, and unlike Mars, have return depth of V from their surface to LEO, which are less than the return from the Moon. Near-Earth asteroids and bodies in the asteroid belt could also be sources of raw materials for in-situ resource utilization. This picture shows illustration of lander on the Moon. Planetary atmospheres. Proposals have been made for mining for rocket propulsion using what is called a propulsive fluid accumulator. Atmospheric gases like oxygen and argon could be extracted from the atmosphere of planets like the Earth, Mars, and the other gas giants. A deep space industries concept for a spacecraft that could retrieve space resources from the surface of an asteroid is shown in this picture. In-situ resource models and technology demonstrations. Oxygen manufacturing on Mars by Mars Surveyor 2001. The Mars Surveyor 2001 project was a multi-part Mars exploration mission intended as a follow-up to Mars Surveyor 98. The Mars Surveyor 2001 lander was intended to carry to Mars a test payload that was to demonstrate manufacture of oxygen from the atmosphere of Mars. The lander was also to test solar cell technologies and methods of mitigating the effect of methane dust on the power systems. This picture shows ISRU concept of a construction strategy from contour crafting. Extraction of carbon dioxide. The Mars 2020 rover mission include a ISRU technology demonstrator that will extract carbon dioxide from the atmosphere and produce oxygen. This picture shows illustration of the 2001 Mars Odyssey. Production of oxygen on Mars. The Mars Oxygen In-Situ Resource Utilization Experiment is a 1% scale prototype model aboard the Mars 2020 rover Perseverance that produces oxygen from methyl atmospheric carbon dioxide in a process called solid oxide electrolysis. This picture shows the Mars Surveyor 2001 lander. Simulation of lunar soil. Successful tests have been performed on Earth using two lunar regolith simulants. In August 2005, research was conducted on the production of 16 tons of simulated lunar soil, a lunar regolith simulant material for research on how lunar soil could be utilized. This picture shows the Mars Surveyor 2001 lander. Lunar Resource Scouting. The Lunar Resource Prospector rover was designed to scout for resources on the polar region of the Moon, and it was proposed to be launched in 2022. A science instrument are scheduled to be flown on several commercial lander missions. This picture shows NASA's Mars Exploration Program Mars Oxygen In-Situ Resource Utilization Experiment. Testing of ISRU processes. Commercial Lunar Payload Services Program aims to focus on testing various lunar ISRU processes by landing several payloads on multiple commercial landers and rovers. This picture shows demonstration of commercial use of lunar polar volatiles as in-space propellant. You've been watching and listening to In-Situ Resource Utilization, a nation of space-based resources for deep space exploration, presented by Dr. Ayansola Ogundele, Astronautics for Exploit. Thank you.